that's similar. So I'll go to the first slide. Problems. So it's 2017 now. We no longer live in a world where you can get away with just standing up 10, 20 servers in production and things just magically work. You can't pay like an individual to be just a system administrator over these small infrastructure setups. You're talking about now with cloud technologies like containers, virtual machine hypervisors, things like that. You're talking about potentially thousands of servers that can be potentially stood up in hours instead of maybe days, weeks. So you're talking about thousands of servers that could potentially be created, destroyed, within time frames of hours. So there has to be a new way to kind of look at configuration management and deployment of software on these kind of new cloud infrastructure problems. Like I said, so So the other problem is that you have various operating systems with various release cycles, various tools, things like that. I mean, in production, you can see people using Red Hat Enterprise Linux. Some people may be using older versions of that product. Some people may be using Red Hat Atomic if they're more container focused. CoreOS, Debian, I mean, even the non-free Unixes such as AIX, HPUX, or potentially even Windows. And the problem is each and every single one of those targets have a different set of tools available to the user. And a really easy example, if you have a Mac that you can try yourself, is a grep with a -P option. That's the PCRE mode grep, which will not be available on Macs, but will be available on most other Unix systems that are using GNU core utils. So there needs to be some sort of way to create a cross-platform way of solving some of these problems. And then back to the other point of cloud infrastructure, it's extremely important that these machines be immutably configured in the sense that once they're stood up and configured, you shouldn't change them at all. And that's the whole point of this configuration management tool, is that you want to make sure that they don't deviate from these configuration parameters, because then you have inconsistencies which could potentially lead to severe production issues down the line when you're trying to debug why it broke. And since they're immutable, you can kind of version them, so you can track what version broke what. And then again, for rapid deployment, same thing. Since you've created official releases with official version numbers, it's easier to push them through quality analysis, testing, etc. So I'm going to talk about now briefly about some other tools that currently solve some of these problems. There's three I listed here: Ansible, Puppet, and Udeploy. And they all feature a very similar sort of way of handling this problem. They specifically use programming language features, standard libraries, to create change on the system. The advantage of this is usually when you create a runtime for your language, say like Python on Windows and Python like Linux, they have to sort of implement these standard library features. Many of them usually require, especially in Python, you have the whole OS module, which includes various operating system related ways of tweaking the system. They all kind of offer a standard set of modules. For instance, there's a module in all of these tools for creating new users, creating directories, copying files, templating files, interacting with the init systems on various operating systems, Windows, Linux, etc. All of them use some kind of mechanism, a remote shell to command the host, to command the target machines that you're deploying on. Udeploy uses an agent system. Puppet uses another agent system, which is just a fancy way of saying they run programs on the target machines that sort of act as sort of a remote shell, where your deploying server is able to interact with your target servers that you're deploying against. Ansible is unique in the sense that it only needs to use a standard remote shell transport called SSH, a secure shell. So that's kind of its advantage over the current tools, as long as the target has Python too, I believe, as well. They all offer sort of this, what's considered like an out-of-order execution model, that they're all kind of asynchronous in the sense that you have sort of these rules you want to execute, and they don't necessarily execute in the order you expect them to. So in order to make sure you kind of have some control over ordering, you have these concepts like pre-tasks, post-tasks, regular tasks, and handlers. I can tell you I've had some problems because of this as well. Ansible offers a sort of synchronous mode, which is really slow though. So you gotta be really careful when you're dealing with these tools. You gotta consider sort of the order of execution. Now, talking back to my tool, based on what I've seen in other tools, I tried to kind of come up with a way to make them simpler, especially developing modules. Because my tool does not have a rich set of standard modules yet, since it's relatively new, I wanted to make sure it was really easy for users to create their own modules, publish them on NPM, GitHub, etc., so that people can start using this tool right away. But I also wanted to kind of solve the problem with how the program executes them, the order specifically. So I created sort of a different way of seeing execution, instead using what I like to call these serial and parallel modules. So it kind of restricts what you can do ultimately in terms of controlling execution, but I think it makes it a lot easier to understand, to visualize, to explain. The other cool feature, which I probably won't be covering really in depth, time reasons, is dependencies. All of them kind of expect certain things to be there, either in the standard library or shipped with the ultimate binary you end up executing on the machine. I use various JavaScript libraries and features to sort of do a pre-bundling step of all your dependencies. Makes life a lot easier. Again, like I said, specifically DevOps Foundry is made in JavaScript, unlike Ansible, which is Python, Puppet, which is Ruby, and Udeploy, which is Java-centric kind of application. And because of that, I have a lot of the advantages of sort of the Node.js runtime, such as asynchronous I/O. I have tools like Browserify that kind of go back to this sort of dependency bundling I was talking about. Makes life a lot easier. And strict object key ordering, which is really important when you're doing a lot of templating, especially when I create these sort of executables that I deploy to the machines. This really comes in handy because it makes sure things execute in the order that you specify them to. So for the remainder of the talk now, I'm going to be directly comparing my tool, DevOps Foundry, to Ansible, because Ansible seems to be the really popular kind of free and open source solution that I see a lot of people using, both at Cigna and at Feederroot, etc. So I'm going to start off now talking about execution ordering, since it was one of the bigger problems I was facing, especially when learning Ansible. Like I said earlier, you have sort of these concepts of pre-tasks, task, post-tasks, handlers, and then to make life even more confusing, you have sort of these nested roles which kind of have their own sort of pre-task, task, post-task, and handlers. So a lot of things you have to track. Whereas in DevOps Foundry, like I earlier mentioned, you sort of have this idea of like parallel execution, asynchronous parallel execution, and sort of a serial mode. And the serial module just basically means strictly execute the modules you have defined exactly in sort of the order you expect them to, which is start from 0 and at 10 or whatever, however many modules you have underneath your serial module here. And again, the other advantage is you can nest these, so you can have sort of like a parallel execution tree at the start. You can have like a serial one in one of those parallel steps, which could potentially have multiple parallel modules executing within these sort of serial steps. So I'm going to just quickly show you some sort of like example graphs I made. Graph is. So with Ansible, because you sort of have this pre-task, task, post-task, and handler system, it's better described as almost like a directed graph in terms of how it controls execution flow. So you have sort of like this start. I didn't put an end because I figured it's kind of obvious, but so you have sort of the start, and then you have sort of like these execution jobs. I call them nodes here. So you got like node 2, 3, and then you have sort of these nested roles, which would be like role 1. And as you see, you sort of kind of execute things in a particular structured order. Again, order is not necessarily guaranteed except for nested roles, but again, it's a little confusing. But one particular advantage Ansible has, at least over my tool, is that you have sort of this concept of handlers. So from any one of these sort of like trees, subtrees, you can still kind of call back to some type of central control, so it's kind of like a graph-like structure. It does give you some kind of finer level of control, but it significantly increases the difficulty of sort of handling, sort of visualizing even like how your role will actually execute your playbook. Because you can have handlers that also call handlers that can call handlers, and like I said, it can get very difficult to kind of visualize. This is a very simplistic example. And then now looking at DevOps Foundry, it's more like a conventional tree-like structure. You sort of have these steps that execute in parallel. You have serial sort of steps. And there's no like handler, so there's no way for any of these trees to kind of directly cause things to happen, to kind of join together and execute some code. Instead, you recommend use serial modules, so that way you can guarantee, like, say for instance, you have a bunch of modules that make modifications to like HTTPD. Your finalized step would be, reload HTTPD, so that way it's a little bit easier to visualize. Now, next part, we talk about module development. So Ansible and DevOps Foundry both execute what are called modules. That's sort of like the smallest unit of code that you compose together with these sort of rule books or playbooks. As you see here, like I said, I wanted to make it simpler. One thing about Ansible is that each and every single one of your modules are basically almost independent executables. And what I mean by that, which I'll show better soon, is that they all have sort of their own startup lifecycle they have to manage, where they have to parse their arguments, and they also have to echo out, to your console out, standard error, JSON object to describe if they were successful, failed, or otherwise. And it can kind of get a little difficult to do a lot of your own unit testing when developing Ansible modules, because you have to sort of build your test cases in a way that, like, how Ansible executes them. And you usually have to require some type of Ansible library that does a lot of this work for you in terms of parsing. DevOps Foundry modules are basically just functions. They're literally functions that take argument objects and a callback function. You're not doing parsing, you're not doing serialization of results or anything like that. And because of browserify, like I said earlier, you can bundle external dependencies into your functions, making life a little easier, whereas with Ansible, you're kind of stuck with whatever's kind of like the standard Python library base. Again, like I said, console, no serial output. So here's an example of an Ansible module. This is a very truncated example, obviously because I wanted to fit on the slides. But at the very top, you see arg file. So Ansible will pass sort of what's called an arguments file as the first argument, command line argument to your module. And then you have to read the argument file. And in this particular example, it appears that usually it passes arguments as sort of these shell strings, and that's what the shellx or shellexer does. It kind of just splits out your arguments into sort of like bite-sized little units. And then you have to parse your arguments. Now, I didn't go into example here, but basically it depends entirely on how the argument file is formatted. And then as you see here, this particular module is concerned with changing the date of the system. So basically you have this where you have OS system, date as basically you're just changing the date based on your argument of time. So you change the date to whatever your time argument was. If failed, JSON dumps. Again, you gotta basically take your Python dictionary, serialize it into JSON, and then output it to the console. And then you exit with failed code if you want. There's success, same story. Again, just trying to highlight sort of what I was trying to talk about. This is a DevOps Foundry module. It's much simpler. For instance, it's just Node.js semantics, module exports, function definition, which you can see up there. Basically, you're calling a shell in this case to change this date on the date and time on the system. And then you basically just do return callback. You can put an error message if you want, and then the object, or just object. You don't need to output anything console or anything like that. So just now quickly talk about limitations before I wrap up. Obviously, like I said, less standard modules. I just developed it, so there's It's not as feature complete as Ansible, etc. Node.js standard libraries aren't as feature complete as well as Python's. There's not as many interfaces into the operating system in Node.js. For instance, there's no mechanism in Node.js to resolve user IDs, whereas in Python there is. That's also cross-platform. There's no nested roles. One thing I didn't really get to talk about is Ansible has this concept where you can have sort of like your playbook, which has your module declarations and arguments, but you can also have nested playbooks, which then get kind of loaded into your like master playbook. I thought that kind of starts getting a bit ridiculous to manage because you can have roles within roles too. And no external modules. DevOps Foundry currently cannot handle foreign function interfaces. So basically C++ bindings, whatever word you want to use, but basically modules that have to be compiled on the target machine currently cannot be compiled or distributed with DevOps Foundry. And so basically in conclusion, I hoped it would be simpler to develop modules with this system. Like I said, they're basically just functions. That alone, I think, makes it a lot easier. Control of execution, it's very easy to represent tree-like object instead of like a fully feature complete directed graph. And you can require external dependencies. So thank you. Any questions? Sure.
So it seems like the sort of the framework where you're implementing functions rather than relying on console output is a really strong advantage of what you've developed. I haven't used Ansible before, but so if I have like two separate modules where one module depends on the other, in Ansible, am I having to write or redirect output to a file and then reading in the file?
Oh, yeah.
Ansible.
Yeah, I think I know what you're trying to say. So you're trying to say like if you want modules to sort of like share information with one another.
Right.
Yeah, that's still a problem in DevOps Foundry because it's still, the modules are kind of independent of each other. It's more just they collect sort of this giant object, results object, kind of like how Ansible does as well.
Oh, okay.
So yeah, if you do want to do that, you're going to need to make your modules be outputting something somewhere, temporary directory.
But within a module, you don't need any output for what you've done.
Yeah, so if you want, you can output things to console if you want, but it won't affect the actual execution of the project.
Right.
Sure. As you've been testing, what metrics you're going to look at, like build fails or code defects or like how do you?
It's hard because, like I said, I'm trying to make this tool multi-platform, so different platforms have different problems. So I think the biggest one I want to try and get through is making sure that any machine that can have Node.js installed on it, obviously, I want to make sure that your basic standard modules will execute on it. I want to make sure it executes within a certain time frame, like it needs to be performant. It's really hard because testing is kind of hard for this kind of tool. It's just making sure that your modules are re-entrant as well, which is just a fancy way of saying that if it gets interrupted at any time, you can restart it with the same arguments and it shouldn't cause any problems. So testing's a hard problem for this. I'm really trying to find the word. When testing, it's mostly just making sure that you can execute modules and it creates same results. That's currently my testing targets right now. I have to do more performance evaluations as well. So I hope that answered your question.
That's about time. So
Yeah.
It was announced at the beginning of the session. We've got a 20-minute break. There's some coffee in the student center. I think also most of the posters are set up. It's not